Hi, I'm Wyatt Lindquist, a PhD candidate from Lancaster University, hopefully graduating this fall. Today I'll be talking about MAAT, mobile apps as things in the IoT. In this talk, I'll be discussing how to treat mobile apps as traditional IoT things through a programming enabler we have developed called Actionable Keywords, as well as some of our initial implementation and evaluation work. When considering today's IoT as a whole, we believe the way things interact with other devices in their smart spaces is critical to their utility as a thing. However, to fully utilize these interactions, some challenges must first be addressed. First, how can we program these interactions, and can the IoT help in this matter? And second, how can a user interact, control, and modify the behavior of these interactions within their smart space? Currently, there isn't really an easy or standardized way to do this. We believe that mobile apps that behave like things can play a significant role in these challenges, however. Rather than just APIs, a mobile app software thing can use its user interface to provide new entry points into these IoT apps. This creates a new concern, though. How can mobile apps adjust to these new and unanticipated interactions? To illustrate this, consider a user that wants to record a football game in the World Cup. The user owns a smart TV and DVR and is browsing upcoming games on a World Cup mobile app. Even though the app developer did not provide any explicit integrations with the TV, the mobile app is constantly broadcasting its capabilities and interests throughout the smart space. The TV picks up on this and forms a new relationship with the app. In response, the app modifies its UI and reveals a new button allowing the user to schedule a recording. Unfortunately, while the IoT continues to grow rapidly, such a scenario is not feasible in the 2018 World Cup. As another example, a smart coffee maker of today may offer a redundant internal time service, while a future device may detect and utilize the timer app on the user's smartphone. The user shouldn't need to use small buttons or a minimal interface to configure such a common interaction. Back to the World Cup example, we developed an initial prototype of this scenario using our Atlas Thing architecture. In this prototype, the DVR and app are both tweeting, or sending information on their capabilities to the smart space. Once a new relationship is formed, the DVR sends the information for a new interface to be overlaid within the app, exposing controls for the DVR's API. Modifying the app's UI like this, however, is not straightforward. Creating such an overlay is honestly kind of a hack. It's more of a context switch than a direct integration, and does not allow the app's original interface to be utilized. In this paper, we increase the resolution of this concept, where individual UI elements can be marked by the developer as interaction capable. This is the concept of actionable keywords. An app shares keywords and specific contextual metadata, such as the availability of some time and channel, along with a placeholder UI element specified by the app developer. This UI element, initially hidden, can be matched by another smart thing, causing it to appear dressed up with the styling info specified by the thing device. The user can then press this new button to send an instance of the data, such as a specific time and channel of an active World Cup game, to the thing's API. Here we can see the flow of interactions between app and thing, as well as an illustration of the World Cup example. The actionable keyword represents a set of buttons that can offer some time and channel for an individual sports game, and is given TV-related keywords by the developer. The app can then broadcast this data and keyword information to the smart space. When the DVR is present, the button appears for each row or instance of a game and is styled with a new label, allowing the user to use their selected game with the DVR. Note that the actionable keywords are not tied to sports or a list of views like in our example. Any input widget may be used with an arbitrary set of keywords. Annotating individual elements requires a lot of information from the developer. To encourage them to utilize these features, this overhead must be limited. In addition to a runtime support library that provides custom view components and the Atlas networking features, we developed an Android Studio plugin to help developers create code fragments and choose keywords by searching through those that are already in use by existing things in their smart space. Above, we see the plugin in its keyword search view. Once filled out, the plugin can then generate layout and code fragments like those seen below. To evaluate our implementation, we focused on the perceived activation time. That is, can interactable elements appear fast enough to not be confusing to the user? A thing should match with an actionable keyword as fast as possible. Since the user may not know their app is searching for features, they may not spend enough time within a view to allow for slow changes. Additionally, on the developer side, we created a small user study for the plugin evaluating its utility and ease of use, especially concerning the selection of descriptive keywords. Here we can see some of our initial results, with the elements of our user satisfaction survey to the right and a graph of activation time with increasing numbers of actionable keywords to the left. Our future work will likely revolve around simplifying how app developers can utilize this concept, such as improved keyword searching, suggestions, and inference. Additionally, we would like to expand the actionable keyword concept to support other UI elements in addition to buttons, such as text fields, sliders, and more. That about wraps it up. Thank you for listening.